This is a video for Unit 1, Solving Equations Notes. And we're going to jump right into this because a lot of what we're going to talk about is review for you. So let's begin. Before we even talk about equations, let's talk about expressions, things that do not contain an equal sign like an equation does. So in an expression, we have what is called the coefficient, the variable, and the constant. Let's start with the variable. The variable is a lot of the time something that we always remember. The variable is a letter or symbol. A lot of the times it's x. So in this case, x is our variable. We also have a coefficient, the number that comes before that variable or that's multiplied to that variable. Remember, it could be a whole number or it could be a decimal, it could be a fraction. So it doesn't really matter. In this case, it's a 2, but that could have easily have been 2/3. It could have been 5/2. Okay, so it's any number that's basically touching that variable without a symbol in between. And then lastly, we have a constant. A constant is a number that we either add or subtract at the end. In this case, it's a positive 6. If it were a minus 6, our constant would have been negative 6. We also should be able to tell the difference between expressions, equations, and inequalities. So expressions, remember, only contain like adding, subtracting, division, or multiplication symbols. And if we look down below in this example here, we can see that there's not an equal sign to be found or an inequality sign, which we're going to get to in just a minute. Equations are basically anything that contains the equal sign. So if we look at the example down below and compare the expression to the equation, we can see that the equation now has an equal sign. So here's an expression, no equal sign. Here's an equation, there is an equal sign. And we have two different examples just to show the differences or maybe different ways that you could see an equation. And lastly, we have an inequality. And an inequality is a mathematical sentence that uses not an equal sign anymore because that would make it an equation, but rather a greater than symbol, less than symbol, greater than or equal to, or less than or equal to. So here's a few examples down below. They can look even simpler. It could be something simple like x is greater than 2, or you could have something really complex. These are two pretty basic examples, but just know that anytime that you see this symbol, greater than, less than, anything having to do with those, that would make it an inequality, what you're looking at. Now, since our lesson is talking about solving equations, we are going to just talk about equations for the remainder of this lesson. But remember, expression lingo, so the terminology that I use with expressions, that can also come up, and we will be talking about inequalities, just not yet. So when we solve equations, we have two different methods. I'm not going to go through these step by step right now, but rather when we move on to the next page and actually, or whenever we do solve our equations, I'm going to talk about these two different methods. So the first method is the most basic method. This is probably the one that you came in knowing. So method 1 and method 2. Method 1 is basically, let's call this the balancing method versus the sorting method. So balancing is the basic method. Basically, you distribute if you have to. This is when you add or subtract a number from both sides. Sometimes it's a variable. And we're also going to talk about another method that some of you might actually like better. Some of you might have seen it before. Some of you might not. It doesn't matter to me. We're just going to get practice with both of them. Okay, so if you ever need to go back through and think about, okay, what do I have to do? Flip back to this page so that way you can see the steps. You might want to put like a big star by this or, circle page 12 and say, hey, this is a good page to remember because there's some steps for solving equations on here. So something else we should talk about before we begin solving equations are the different types of solutions that you can get. So pretty much you are used to seeing one solution. It says solve for x and you find a value for x. X is 2. X is in our example down here, we can see that x is 10. So one solution, one number that x equals. There's also a few other different types of solutions. We can have something which is called the null set, which is no solution, or the identity, which is infinitely many solutions. So the way that we can tell is by looking at an example. We come up with this here. And we notice that to get from this step to this step here, since we have 3x's on both sides, we're going to subtract away 3x's. And 3x minus 3x gives us 0, so there's nothing. And we have 0 is equal to 4. So really the 0 is on the right-hand side here. It kind of moved to the left-hand side, but it's not a big deal. What we really care about is the statement 0 equals 4. We know that 0 never equals 4, so there is not a solution to be found, and we would just write no solution underneath. Now on the flip side, we sometimes might notice that the same exact thing appears on both sides of an equation. So I have the expression 4x plus 2 is really the same as 4x plus 2. Well, yes, it will always be the same. 4x plus 2 will always equal 4x plus 2. So for those of you that want to take away 4x from both sides, you'll see that 2x is, or excuse me, not 2x, just 2 is equal to 2. So because we have the same number equaling itself, yes, of course, 2 will always equal 2. This is different. 0 will never equal 4, so because 2 will always equal 2, we're going to write infinitely many solutions. Now, I just went through that pretty quick. Don't worry too much about it. We're going to see some examples of this, but this is just a little bit of a background, some nice review for all of you, just to kind of refresh your memory. Down at the bottom of this page is basically just something as a resource for you, so that way if you ever want to check your answer, we can use the TI Nspire, or we can use the iPad app of the TI Nspire to check. And all of these steps are down below. Certainly we're going to focus more on this when you're practicing it in class, but here is just a quick way that you can go back and see if you're following the steps right, if you think that something is coming up, like you get an error message or something, or you just simply forget how to check your answers. We're going to use our calculators as a checking tool. We're never going to use them as a crutch. We are going to use them as a tool to help us attend to precision, to be precise with our answers, to make sure that we're right instead of wrong. Okay, so we have a page of lots of examples, which is great. So we can see that there's a sorting method. So it looks like examples 1 and 2, we're going to practice with the sorting method, but as we move on, we might do the balancing method. The sorting method is actually probably new for many of you. So let's jump in. So the first thing, if we look at this equation, negative 3 times x minus 1, all minus 4, is equal to negative 2. I can see that I have some parentheses, which means I am going to distribute that negative 3 to both the x and the negative 1. So negative 3 times x is negative 3x, and negative 3 times negative 1 is positive 3. I'm not going to forget about that minus 4 on the end, or equaling negative 2. Now the sorting method. What I tend to find helpful is just drawing a line down the equal sign to show you what I mean by sides of an equation. So this is what I mean by the left side of an equation, and this is what I mean by the right side of the equation. On the left side, we are going to put our variables, and on the right side, we are going to use our constants, or move our constants, rather. So negative 3x. Well, since negative 3x contains a variable, negative 3x is going to stay on the left-hand side. However, that plus 3 is not a variable term, so it's going to move to the other side of the equation. But if I move a positive 3 to the other side of the equation, we're actually using its opposite. Okay, we're going to put a negative 3 to the other side. The additive inverse is happening. So if we look at this minus 4 here, We can see that it does not have a variable, therefore it needs to move to the other side. But instead of being a -4, you got it, it's going to be a +4. And we have a -2 on the right-hand side of our equation. Is that on the constant side? Well, it sure is, so it's not going to change at all. So we're just going to bring down a -2. So what we've done here is we've sorted. We've grouped all of our variable terms, in this case there just happens to be 1, with all the variable terms, and we've grouped all of our constants on the same side of the equation. So the next step we're going to do is we are just going to make this look simpler. So -3x, can't make that look any simpler, but we can combine a -3 plus 4 and -2. Do not make careless mistakes with integers at this point. I'm assuming that you know your integers, but if you ever get stuck, use your calculator to help you. So a -3 plus 4 is 1. 1 minus 2 is -1. Now, some of you might think, oh, I know what to do here. I'm going to divide both sides by -3 to get x alone. And you are right. So we're going to divide both sides by -3, and therefore we get our final answer as x is equal to, and instead of dividing this out and getting a repeating decimal on my calculator, I am going to say that a -1 divided by a -3 is a positive 1/3. And there's my final answer. Something I would also like to point out is that we found that there was one solution here. So as you can see up top, it says one solution. This is an example for one solution. So moving on, let's notice up top it says that we're going to use the sorting method and that we are going to get the identity. Basically what this means is we should find that there's infinitely many solutions when we're done solving. So let's look at the equation. What do you think we do first? If you said distribute, you're right. So let's multiply the 2 times 4x, and 2 times 4x is 8x, and 2 times a +1 is +2. So we have 8x plus 2 is equal to 8x plus 2 itself. So some of you might be able to stop right here and say, hey, the same thing equals the same thing. This is the identity happening, and you'd be correct. But for those of you who want to go a little bit further, and it does say use the sorting method, so let's keep going with this. So I'm going to draw my line down the equal sign. I'm going to put my variables on the left and constants on the right. If you want, you can always flip that and say constants on the left, variables on the right, but usually I think having the variables on the left is better. So let's look at this first term of 8x. 8x stays because it has a variable. Okay. Never forget that equal sign. A lot of people forget that, and it's important. We need to show that there's a balance happening. This +2, well, it's on the wrong side. It doesn't have a variable, so it's going to move to the other side and become a -2. Take a look at this 8x on the right-hand side. That's got to move over because it has a variable and it's on the constant side. So we're going to move it to the other side and make it -8x. And then lastly, this +2 doesn't have to change sides because it's a constant, so we're just going to bring it down. So let's move on. 8x minus 8x, we're going to group these together. Well, that's nothing. A -2 plus 2, that's also nothing. So because we ended up with getting 0 equals 0, if we had gotten 10 equals 10 or 30 equals 30, anything equaling itself is going to show the identity. So let's write out infinitely many solutions. Okay, moving on to example number 3, we can see that there's some fractions in here. And I know that you've worked with fractions and equations in the past, and some of us might use different strategies. So first let's point out that we are going to use a balancing method and that there should only be one solution when we finish solving. So I'm looking at my equation here, and I notice that there's a denominator of 4 and a denominator of 2. Also here, there's a denominator of 1 that we can't see, but I'm just going to take a minute and draw it in there. just to help me keep things in line. So what I want to do is find the least common denominator. So basically the smallest number that both 4, 2, and 1 divide evenly into. So some of you might like to write least common denominator off to the side. So the least common denominator here, well, what number can 1, 2, and 4 all go into, divide into? And that would be 4. Some of you might have said 8, and that actually is fine. So any denominator that every single number can divide into will be okay. We like to find the least one because it makes it a little bit simpler for us. So what I'm going to do here is I'm going to multiply everything on the left side by that least common denominator and everything on the right side by the least common denominator. But keep in mind that when I multiply, I can always divide out the denominator. So 4 divided by 4 is 1. So I am only going to be left with 1 times x plus 1. And some of you are like, did I really have to write that? No, you didn't, but we're going to just to show that we multiplied those two. Moving on, so let me just draw on the arrow. We're distributing here, so I just multiplied 4 all times the x plus 1 over 4. And now I'm going to multiply 4 times 1/2. Now what I would recommend that you do right now is use your calculator just to make sure that you aren't making mistakes. But I'm going to, of course, talk you through the math correct way. So 4 divided by 2, so divide by that denominator, 4 divided by 2 is 2. And then I'm going to multiply by this numerator here of 1. So 2 times 1, and of course it's a negative, is minus 2. And that all equals, well, can't really divide 1 into 4 and be left with anything smaller than 4. So 1 goes into 4 times, so I'm still left with that 4. 4 divided by 1 is still 4. 4 times x, however, is 4x. And let's just clean this up a little bit in the next line here. I'm going to multiply that 1 times x plus 1, and of course you are all saying, hey, that doesn't change. 1 times x plus 1 is still going to be x plus 1. So really we're just eliminating those parentheses. Okay, so now it tells me to use the balancing method. So I'm not going to sort like I did in examples 1 and 2. I'm going to balance this. So I see that my left side is pretty complicated. So what we should do is just move that to the other, this x to the other side. So this is a 1x, so I'm going to take away 1x from this side and 1x from that side. Remember, we always want to move our variable terms first. So 1x minus 1x is 0. So I'm left with 1 minus 2 is equal to 4x minus 1, which is 3x. Then I'm going to combine 1 minus 2 on the left-hand side, which of course is negative 1. And that all equals 3x. And my last step, I need to get x alone, so therefore I'm going to divide both sides by 3. So x is equal to negative 1/3. One solution. Okay, so question number 4 wants us to use the balancing method, and we should get no solutions. So the first thing that I notice is that number 1, I have fractions, and number 2, that I have some distribution that needs to happen. So I'm actually going to distribute first to help make things a little bit simpler. So after I do that, I end up getting 2x minus 14 all over 6 is equal to x minus 1 all over 3. Now we could, if we want to, we could find a common denominator, but I actually don't think I want to do that for this one because I have a fraction set equal to another fraction. You got it. It's a proportion, and if it's a proportion, that means we can cross multiply. So let's do that. I'm going to multiply my numerator with the denominator on opposite sides of each fraction. So let's multiply first. 3 is going to be multiplied by 2x minus 14. And on the other side, we will get 6 all times x minus 1. So notice how I use those parentheses to show that I have to distribute. So let's go ahead and do that on each side. I have to distribute the 3 on the left side and the 6 on the right side. So I end up getting 6x minus 42. And on the right side, I get 6x minus 6. So it tells me, go ahead, use a balancing method. So let's do that. I can see that I have x's on both sides, and it really doesn't matter where I move either one of them to. So let's move this one. Let's move that 6x and balance it out. So 6x minus 6x is 0. 6x minus 6x is 0. Okay, my x's cancel out. So I end up being left with, or I'm left with negative 42 is equal to negative 6. Notice how I'm not bothering to write in 0x. I don't care. That whole term disappears completely. I'm not going to write an x in there. And I have a question. Will negative 42 ever equal negative 6? Never. It's never going to happen. Therefore, we have no solution. All right, 4 down, 2 more to go. So number 5, we need to use a balancing method, and we should end up with one solution. So let's jump right in. All right, well, I see that I have some decimals. It doesn't matter to me. I have a calculator that I can use all the time if I ever get stressed out with decimals, which you shouldn't because they're just numbers with dots in them, basically. So don't freak out, just a decimal. So we have 3 and 7/10 x is equal to 10 plus 2 and 2/10 x. And we always want to move our variable terms first. You got it. So we are going to look at the more complicated side. Which side is more complicated? Oops, the left side or the right side? To me, the right side looks more complicated. So let's hone in on this here and move it. So it's a plus 2 and 2/10 x. So let's subtract 2 and 10 x from both sides of the equation. Okay, after we do some subtraction, first we notice that this becomes 0. We picked that because it's the additive inverse. So 3.7x minus 2.2x, we get 1.5x is equal to 10. And our last step, in order to get rid of multiplying x by 1.5, we are going to divide both sides by 1.5, and we end up getting x is equal to, why don't you take a minute, divide that out on your calculator. You should get 6.6 repeating, and it's okay to leave it as a decimal or a fraction. In this case, I'm going to leave it as a decimal. Do not type in 6.66666667. We should know by now that that 7 at the end means that the number just continues on, and our calculator is not as smart as we are. We know that it's rounding. The calculator is just rounding for us. So don't make that mistake. Make sure you put 6 and 6/10 repeating without that 7. Nice work. So we have reached the last question, question number 6, and it looks like we are going to find one solution by using the sorting method. For those of you, just a quick memory refresher, the sorting method is probably the one, the method that you just learned today. So question number 6, we see some parentheses. What do you think we're going to do? Well, we're clearly not going to call Ghostbusters. Hopefully you guys got that cheesy joke. We're going to distribute. So we end up getting negative 1 is equal to half of 6. What's half of 6? Well, if you're not sure, you can always do 1/2 times 6, type it right into your calculator, but I know that that's 3. So 3m. I also have to find half of negative 8. So what's half of negative 8? Well, that's negative 4. 1/2 times negative 8. Now we are going to sort. Remember, variables, constants. What do you think about that negative 1? Do you want him to stay or go? I hope that you're saying make him go. Move him to the other side and make him positive, or her. And then that 3m is on the constant side. Move it on over to the variable side. You got it. Make it negative 3m. And bring down that negative 4 because it is a constant. So now we have all of our variables grouped together on the left side and constants on the right. I get negative 3m is equal to whatever 1 minus 4 is. Hopefully you know that that's negative 3. Our last and final step is to get rid of the coefficient in front of the m. So let's divide both sides by a negative 3. So my final answer, m is equal to a positive 1. Great work today, guys.